Hello, my lovely humans. Right, so we're going to look at today the 2023 question 5B question. It's uniform accelerated motion. And we're just going to have a look and see which of the two scenarios it is. Usually in the applied maths questions, there's kind of two options for the UAM questions. One is where it's a train leaves and it does stuff, and the total time is this, and find an expression for that. So it's like a one situation problem rather, a single situation. And then the other one can be, I think last year was John and Kevin are on motorbikes, and when do they meet together, or when are they furthest apart, that kind of thing, where there's two things happening at once. And this question about Aine is the same kind of idea as that. It's the thing isn't happening at once, but it's two different situations that are related somehow, and we use that relation to solve the problem. So this one is Aine travels by car from her house to work each morning. On Monday, she starts her car and accelerates uniformly for that to a speed of that. Aine then travels at this speed for 8 minutes until decelerating uniformly to rest at her work. We already have seconds and minutes, so that's what we have to be careful of. And then she reaches her work at 8:30. So each morning, so she does. So I presume the next time on Tuesday morning, I presume it's the same distance because it's the same trip each time. She accelerates uniformly. That's part one of that trip. Then she travels at this speed, so that's your constant at 8 minutes. But again, 8 minutes, I think we got to turn that into seconds. And then decelerating uniformly, and we don't know what that is. Now, some of the marking schemes will use F for your deceleration, some will use D, which isn't confusing at all. I'm going to use A1, A2, A3, because we have three regions. We have the acceleration, we have the constant, and then we have the deceleration phase in that trip. And then on Tuesday, she leaves her house 140 seconds later. She takes the same route to work, so the distance is the same. Okay, so that's how we're going to relate to two things. We're going to find the distances, put them equal, and then hopefully something will happen. She starts her car, accelerates that, maintains the speed. So we have an acceleration phase, we have a constant speed phase, and then we have a deceleration phase. Now, we don't know the deceleration in either of them, but that's interesting. And then she reaches her work at 8:30. Now, with these uniform accelerated motion questions, we have our equations from our tables, page 50 something. Again, back in my day, it was all on page 9, so page 53, I think it's 53, eventually after many years, not 53, 50, exactly 50. We can use those things, and we're going to need to use them, but we also can use the properties of our speed time diagram. And I think we're going to need to draw two speed time diagrams here, one for the Monday trip and one for the Tuesday trip. So I'm just going to grab a set of axes here, just plonk it there just because I can. Okay, so again, there's lots of different ways to start it. You can start it by doing other, what do we know is true, like naming things, but I'm just going to jump into Monday. I'm going to make that even smaller because I don't think we need it to be that big. Okay, so let's say this is Monday. Forgive my writing. So on Monday, she starts her car, so she starts here at the bottom at 0, goes for 40 seconds, up to a speed of 22.5. And let's pretend I can draw a straight line here, so it's roughly to there. So she accelerates uniformly, so it's a straight line. Again, you guys have rulers, please use them. Then 8 minutes, so 8 minutes in seconds is 480. So that's 480. So I'm going to draw a little line here. Go cross that. So that's our second region. And then she decelerates. And we don't know anything about the deceleration. We don't know. We do know the height, but we don't know the width. So I'm going to call that T3 because we don't know that. And that's S1, S2, and S3 for the three distances. We do know that we don't know the acceleration here. We know there's no acceleration in region 2 because it's a constant speed, and we don't know the acceleration 3 there. So I suppose what I would do now is I would kind of information gather what I can from this. What do we know? Well, we know the distance, and we're going to call this distance Monday. So SM equals S1 plus S2 plus S3. What do we know then? We know our distance 1 is UT, U is 0, UT of T is 40, so it's 0 by 40 plus a half A1 by 40 squared. So UT plus a half AT squared. So that's 1600, that's 800 A1, I think. So that's our S1. Okay, now can we figure out A1? Oh, I think we can. We can use our V equals U plus AT to find A1. Again, I'm doing this without having prepped it, so you can kind of feel what we would expect in an exam, that we do something we know we can do, and see where does that take us, or what can we figure out how to do then. So if we can know A1, we can know S1 perfectly. So actually I realize we can get S1 without even that, but anyway, let's go. We're here now. So we know 22.5 equals U plus AT, so 0 plus 40 A1. So that means A1 equals 22.5 over 40, which is 0.5625, which is nice. Well, not nice, but then multiply that by 800 and gets us 450, which is definitely nice. So S1 is 450, means that weird 0.5625 is quite likely perfectly correct. So this S1 is 450, and I'll just write that in as a diagram, 450. Now I realize I could have used the area of a triangle formula, because the area of that triangle is S1, and if you do a half by 22.5 by 40, you get half by 22.5 by 40, you get 450. So yeah, I could have done that, which is what we can do for S2. Actually, we can get the area of that rectangle here for S2. So S2 is, and again, I'm speeding through these things, not pausing, because you can pause the video yourself and go backwards and make sure you understand, and then move on when you're ready. So the area of S2 is our 22.5, and actually it's S equals UT, because there's no acceleration. So UT, so 22.5 by 480 is S2, sorry, S2 is 10,800. Okay, and that's all we can definitely figure out, because in S3 here, we don't know the acceleration, we don't know the distance traveled yet, and we don't know the time yet. So we can't really do anything except possibly write down what the equations of motion tell us. So one thing we know would be 0 equals 22, so V equals U plus AT, sorry, 22.5 plus A3 T3. So that's something. I'll draw proper 3 there. There we go. So that's something we might be able to work, and actually that's nice enough because that gives us A3 T3 equals minus 22.5, which is correct because we know it's a deceleration and it is negative. Because this thing, the slope of this is downwards, that has to be negative. So that's good that we are on the right track, hopefully. So that's one thing we know. And we also know our S equation, S3 equals UT plus a half AT squared. So that's 22.5 T3 plus a half A3 T3 squared. And maybe that'll be useful very soon, but we'll see. So I'm not really sure what to do next. Apart from, I think we've done everything we can in this thing because we have S1 and S2, which is great. We've got some kind of understanding of what the problem is for S3. I think we need to look at Tuesday now, I think, and do what we can, get as many of these attempt marks as possible, and then see if we can get an actual answer. The actual answer again is only worth 5. This whole thing is 25 marks, so we've probably passed the question already, but we'll see. So we're gonna have a look at Tuesday now, and I'm just gonna pop Tuesday into the side so we can see that it's very similar. So let's problem solve Tuesday. So, wait a minute, she leaves her house 140 seconds later than the day before. Wait, I didn't spot that the first time. So I read it, but I didn't get how it was going to be important. So 140 seconds later, but she arrives at, she arrives at 8:30 the same, both days. So what's going on here is that the Tuesday trip takes 140 seconds less than the Monday trip. So, okay, so the total time, so I'll just write it here. The total time on Monday which one's bigger? She leaves later, so it's basically the time on Tuesday. So so we've 140 seconds in the difference. We just got to figure out is it plus or minus. The Tuesday one is the shorter one, isn't it? Because she leaves later, arrives at the same time. So yeah, so she leaves her house 140 seconds later, but arrives at 8:30. So the Tuesday one is smaller. So we need to add that 140 on. So that's one thing we are definitely going to need. And we also know that the distance on Monday and the distance on Tuesday are the same. So that's something we can do. And what is Tm? Tm is T1 plus T2 plus T3. Okay, so I'll just write that down. So the time on Monday is 40 plus 480 plus T3. Okay, so hopefully that's going to be useful for us. So that's 520 plus T3. Right, so I know I've jumped around there, but that is the nature of this beast, that we're going to be jumping back and forth when we spot things. So let's do our speed time diagram for Tuesday. So now again, she starts from rest, accelerates for 20 seconds. Okay, so we know that that's 20. We don't know this V1 here. So she gets to here, so it goes like that. And we know the acceleration is 1.5. Then for 6 minutes, she goes across. again, diagram not to scale. 360 seconds is 6 minutes. And then, actually I'm going to call that A4 just so there's no confusion. I'm going to call that T6. I'm going to call that A6. I'm going to call that S6 because S4 and S5. Just don't want to have S1s, S2s, S3s, kind of, and A1s, A2s, A3s confusing us. So maybe we should keep that as V4 then. Right. So let's do the same thing with this. So what can we figure out? We can figure out V, and from that we can figure out S, I reckon. Or sorry, V4, we can get S4. So V4, the constant speed is 0 plus 1.5 by 20. So V4 is 30 meters per second, which means then S4 equals a half by 20 by 30. Remembering that, now I know, remember I can use my triangles, so that's 100, 300. Then S5 is UT, so that's 30 by 360, which is 10800 if my mental arithmetic serves me correctly. And S5 and S2 are the same. Okay, cool, interesting. Nice coincidence there from Mr. SEC or Ms. SEC. And then S6 then is a half by 30 by T6. Which is 15 T6. So the pause there was that I realized I could have done S3 using the triangle here after me saying triangles. So S3 is also the area of that triangle, which is a half by 22.5 by T3. Okay. So what do we know? We know the time on Tuesday is 20 plus 360 plus T6. Oh, and we know that the TM from earlier, TM equals so the time on Monday equals the time on Tuesday plus 140. Now I've sped through that, so do pause and go back and make sure you're happy. But we do have something now. We have 520 plus T3 equals 20 plus 360, which is 380, plus T6 plus 140. What's 140 and 380? That 140 plus 380 is 520. So this is where I would be, if I were you guys, I'd be worried because it doesn't feel like it should be making sense. It doesn't feel like we should have 520 on both. If it was me, I would be beginning to worry and I'd be going back to check because that seems like too much of a coincidence. Or I'd want to go back and check. But I think just trust that what you've done is correct. If it is wrong, you might find out later, or you'll have made one slip and you'll get talked to Mark. So don't worry too much. So T3 equals T6. maybe that is how this thing works. So let's just trust that what we've done is correct. Jeez, I'm jumping left and right, but anyway, you guys have pause. So we've used the times because we know they've 114 the difference, and that has given us something. What about the distances? We know the distances are the same. Yeah, distances are the same. So let's just write down the distance on Monday is 450 plus 10,800 plus S3 so okay, we'll leave it there. We'll tidy it up in a second. And the distance on Tuesday is the same as that. But what is that? That is S4 and S5 and S6. So 300 plus 10800 plus S6. So what do we do? Wait a minute, we know S6 is 15 T6 and we know S3 is that. So actually let's put both of those in. And we know these things are equal to each other because they're the same distance. So let's do all of that in one go. So we'll put the distance on Monday. So we put SM equals ST. So 450 plus 10,800 plus S3. Well, as we know, S3 is a half by 22.5. Half of 22.5 is 11.25 T3. And that equals 300 plus 10,800 plus 15 T6. But we know T6 and T3 are the same. Okay. So it's 15 T3. And here's where my laziness paid off, is that I can just cancel those 10,800s. Move the 300 over to get 150. Move the 1125 over to get a 3.75 T3. Again, 15 minus 11.25 is that, so just make sure you're happy. And then we divide across by 3.75 and we get 3.75 is 40, which chances of that being wrong are almost nil. So T3 is that. So we can be fairly sure that we got full marks on that one. Even if we didn't, our process is bang on. So that's our T3. So we now kind of know everything. Well, what time does she leave her house on Monday morning? So okay. So how long does we want to arrive at 8:30? So how long does the trip take on Tuesday? So TT. So time on Tuesday is 20 plus 360 plus 40, which is 420 seconds, which is 7 minutes. So 8:30 minus 7 is 8:23 a.m. and that is your answer. Now, I've been doing the question as if I don't know what's going on and I didn't know how we were going to do it, but I have been checking the marking scheme as I go, so I know that that is correct. Just didn't want to waste your time with too many mistakes. So this is the only question here. What I'm going to look at now is where the marks are got. Now, it probably seems like we do a lot of work, and we do a lot of writing for this one, but by doing lots of writing, we're thinking as we go, and we're getting the marks as we go. So where are the marks got? So you get 5 marks for getting SM and TM, and 5 marks for getting ST and TT. So how do we write this down? So I'm going to put in yellow the stuff that we get for, so by getting to here, so getting that thing, getting this thing, then by getting S1, S2 and S3, even just 1, 2 and S3 itself without any number. So that's, you got 5 marks for the yellow stuff for Monday, and we get 5 marks for the same yellow stuff for Tuesday. So that's 10 out of the 25 for that stuff. We got also 5 marks. So actually, I'll put the highlight on there. Then green, we got 5 marks for this. Now the marking scheme shows in a different order. I need to make that pen bigger because that's too annoying. So we got 5 marks for that, and for kind of knowing both of those things. So 5 marks for being able to relate the times on Mondays and the distances being the same. Space pen isn't working over the green. So that's 15 out of your 25. Then you got 5 marks for our answer here. So 5 marks for T3 equals 40. And then 5 marks for getting the time itself, which seems insane because once you get to 7 minutes, you really should be getting that for free. So no matter what time you get, if you, like, even if it is minus 39 minutes, whatever, if you get something ridiculous and wrong, if the time was minus 7 minutes, you put down 8:37, you get 5 out of 5 because that is what your calculations have shown. So that 5 marks at the end, no matter what answer you get, you should get full marks for that. 5 marks for understanding it's the same distance and understanding the times are separated by 140. And then the speed, distance, time diagrams, the stuff in yellow there, is stuff you do in every single question. So that's not new. So really you're looking at 20 out of 25 without doing any of the problem solving. That is unique to this question. So really the process is key, and above all else, if you have a process to solve these things, you will get 20 out of 25 because you know how to break it down into the bits you need and build it up slowly. Again, throw any comments and any questions or suggestions or requests into the comments, and I will happily throw up another video for you. I hope that helps. Good luck.